Action.
So physics, we took a quiz that was 6, 6, and 7 reworked to end the chapter, but probably not do a trade grade on that, just so we have time to cover homework. So where we are in our chapter, 19 to 27 is due today, so we'll look at that in a minute. 11 to 18 was yesterday and we didn't get to it, so we'll look at that now. What's due tomorrow is the chapter review. There's 10 questions, there's 4 problems, and then there's applying physics 1 and 2. And then what's due the day after tomorrow, the review sheet that I typed, the practice test from chapter 6 is the next day. So 11 to 18, we're doing stuff with weights and masses. So what's the equation when you're dealing with weights and masses?
W equals mg.
W equals mg, where the g always is the number 9.8. So if you want to get a weight, what are we doing with the 9.8? Multiply. And if we're doing the other way, we're going to divide. So 12, let's see if we can get 3 different voices. 12a, a voice.
10.
It is 10. A different voice for 12b.
Give me 2 seconds. 1 and 2. 4.2, 1, 4.
Would you say?
4.2, 1, 4.
Something funny there. Anybody 12b?
8.16.
Yeah, 8 in the 8.2 range works for me. And then for C, a third voice. 0.1 works for me. 14, anybody, whether we voiced you or not so far? It's over 7,000.
7,840.
That's true. 16 is less. Anybody 16 with comfort?
1,500.
It is 1,500. A different voice for 18A.
Is it over 11,000?
It is.
11,760.
Yeah, my book rounded it to 12,000, but yeah, that sounds about right. For B, we don't use W equals mg. We use another equation for the first time this day, but it's not the first time we've used this in this chapter. What's the equation that we can use when they start talking about accelerations? F equals ma. If we use F equals ma, anybody 18b? Flies are tough. I mean, he wants them to stay right outside my reach.
And your nice book too.
I mean, mint condition. Oh, that book. I thought you meant this one for a second. We did answers. We're waiting for 18b. No one seems to have done F equals ma. It got real quiet.
Is it 300?
No. 18b. Somebody do me an F equals ma.
I'll see what I can do. Did you get it?
No, he's quick.
39.2? Is that what you just said?
No, I said 300.
Okay, I don't know
I
what I
got that
did.
same.
I don't know what I did there.
You get them? No.
And do some of it.
Not sure why it's taking quite so long. What's the M? Are people on page 1 or 2? Are you looking at it?
1,200.
Yeah, and the A?
Oh.
I see what I did.
4.
wrong.
It's 4,
Four.
so
4,800.
4,800 newtons is a win.
I think I divided.
Okay, I feel vindicated. That
I don't know
wasn't
what
that
she
hard.
did, but I got the same thing
Me?
as her. Yeah.
I
Okay.
did times 9.8. I
That's what I
didn't
did.
learn this yet.
Anybody 11 to 18 need any troubleshooting on that one? That one was not too bad. 19 to 27, they took you up a notch. The issue on 19 to 27 is we have 2 kinds of forces. What are the 2 options for force categories?
Net and applied.
There's net forces, there's applied forces. Which of those 2 is what goes into the equations?
Net.
Net. The net's the one that's more, or the net's the one that's less?
Less.
It's less. So what they have going on in most of these questions is some of the horizontal things, they have an applied force, but you can't put that into the equation. You have to put in a net force. What do you do for horizontal activities? Friction. Do what with friction? Add,
Subtract.
subtract. Generally, you'll have to subtract friction and then go to the equation. If they're going lifty stuff, we don't care about friction. What we care about is the
Weight.
We have to usually subtract the weight. If it's F equals ma we're trying to do, we have to get a net force. You usually have to get that fixed first and then go at it. On an occasion, they'll have you instead solve for an applied force, so they'll give you enough information that right away you can use the equation to get the net force. Then how would you transition to an applied force if that's what we seek?
You add something.
We'd add, yeah. And if it's horizontal, we'd add on
Friction.
the friction. If it's vertical, we'd add on the weight. It was mostly F equals ma, but there's some W equals mg's because we need the weight sometimes. They also broke out a couple old equations, like the velocity, distance, acceleration equations. They broke out an old thing or two of those. So we'll see how this treats us. So 20, anybody with confidence?
200 N?
200 is involved, but our problem is when you go do F equals ma, what kind of force does that get us again?
Fixed. No.
That gets us.
Net.
Gets us a net force. But they asked us for, what did they ask us for on 20? Applied force. So we have to get that 200, but you're not done.
So is it 2 times?
It is not. What did we say we had to do to get from net to applied?
You add.
We add. Add what when we're vertical?
You add.
Weight.
Add the weight. We don't know the weight. So
find the weight.
you have to go find the weight. How do you find the weight?
W equals mg.
W equals mg. Using which number they gave you?
20.
20. So somebody use the 20.
So is it 4?
No.
Oh, that number.
196.
It is 196 for the weight. So the grand total,
396.
396 newtons for 20 is a win. 22. We have to go get acceleration on 22 before we can do anything else. Can anybody tell me how on 22, if you have the 30 meter per second velocity and we bring it to rest, we have a distance of 100. Can anybody tell me what equation you could be used from old days that gets you the acceleration?
Is it
A equals
S?
S over 2.
No, it's like.
No,
VF
because we don't know T's.
square root 2AS.
Say what?
Is it VF equals square root 2AS?
It is. What we need to do on 22 is use VF equals root of 2AS, and that can get us an acceleration. Did anybody get an acceleration? Okay, so don't give me that paper, it doesn't seem like, because we're not off to a roaring start. So what we want to do on 22 is get the acceleration with the VF equals root of 2AS. Then why do you have a little bit of trouble using F equals ma, which is where we're going to go? Why can't we still use F equals ma after we get the A?
You don't have the math,
You don't have the mass. How are you going to get the mass?
from
From
Newton's,
the newtons, because the newtons is telling you the
the weight.
weight. How do we get from weight to mass?
Divided.
Divide 9.8. So 9800 divide 9.8 will get you the mass. That old equation we said can get you the acceleration. Then it'll be F equals ma on 22. Then you repeat the process but with 10 instead of 100 and see where that takes you. 24A is easy if you actually tried. A should be not a big fuss. Anybody? 24 part A?
0.5.
Say again?
0.5.
No, something weird happened there.
Wait.
1.5.
1.5 is a win. 24A is 1.5.
Oh, it's like It looks like my
I
dash.
was one
Okay,
step behind.
so you had it.
Yeah.
For B, we're trying to use F equals MA. Are you gonna use 14.7? Are you gonna use 10.2? Or are you gonna use neither one? You have to use some force you have to figure out.
Probably figure out the force.
It's a good guess. Yeah. The 14.7, what is the 14.7?
The weight.
That's the weight. What kind of force is the 10.2?
The
That's
other
its-
one other than
that's
that.
its-
The one that's not net, what's that called?
Applied.
Applied.
There you
And
go.
that's non-helpful. So if we have an applied force of 10.2, the rocket has an applied 10.2 force, but it has a weight of 14.7.
Subtract.
Subtract those, that's gonna be 4.5. Then you could do F equals MA. We have an F of 4.5, we have an M that we figured out in part A. We can solve that for acceleration. Acceleration's a vector, which means it has a
Magnitude, direction.
and a direction, so we need a direction. Where's this rocket going if the weight is 14.7 and the applied force is 10.2?
Is it?
Down.
Down.
It's,
So you're gonna get something and also say down.
Oh,
Anybody 24 have it? So keep the paper, go get it. 26A is easy if you kept on chugging. We have a mass, we want a weight. How do you make that jump?
divide 9.8.
Divide, no,
Multiply 9.8.
multiply 9.8. So 26A is pretty easy money. Have it? Yeah, so go get
Oh,
it,
wait,
somebody.
49.
49.
It is 49.
Let's go.
For B, we have a upward force of 98. That's an applied force. You can't jump on and do the equation with an applied force for B. What are we gonna have to do B?
Get the net force.
Get the net force. How?
Subtract.
Subtract who?
5.
No.
Or wait, the weight that we just
The
got.
weight-
49.
Yeah, the weight of 49 we just got, subtract
And then
it,
the applied force.
the applied force. Correct. If we do that, then we're gonna go F equals MA. See where that goes. C, we need to go old equation. We need a velocity. So what we had going on here is we started from rest. I believe, I don't think it said that it started from rest, but it's just sort of common sense. If you load your equipment in a weather balloon and turn it loose, you're starting from rest. You don't try to load your equipment in a moving weather balloon. So we start from rest. We have an acceleration we know from B. We give it 10 seconds worth of time. You want to know the velocity later.
VF plus VO, or VF equals VO plus 18.
We're going to use VF equals VO plus AT, and that'll win us an answer for C. Then while the stuff is rising, it gets cut loose. It's like hanging from a string or something, and they just cut this loose, and the instruments are just on their own. They're let loose from the balloon. For D, what is the force acting on those instruments if you just chuck them overboard? The only force at that point is its
Gosh. What?
Wait.
It's a weight.
Oh.
And we know the weight from earlier, so D is the weight we had from earlier.
49.
Then E, here's a question that appeared on the quiz. So we have a rising thing. There's stuff on there, and we just drop it. What's going to happen to that stuff if we're in a rising balloon and we drop some stuff?
It goes up.
It's going to rise for a little while,
And then pause.
pause,
Go down.
and then it's going to drop. So what we're doing for E is we're going to use the same equation we just said a second ago. We're going to go VF equals VO plus AT again. The VO is the answer you got from C. What's the A once you cut it loose? 9.8. And we're going to go get a time out of that. And there's your coaching for the even ones. The odd ones are in the margin, so you would have already known if you were right or wrong, good or bad, and you would have had a chance to try again until they were good. But sometimes you fool yourself. If you just like push buttons until the blue appears, sometimes you think like, oh, I got to figure it out, but really all you did is push buttons until the blue appeared, and without the blue you might have never gotten there. But does anybody on the odds have any of the blue stuff that you need some like insight as to what's the real way to get it other than push buttons until the blue answer comes out?
Time to try to make guys.
Anybody 19 to 27ers?
Why am I not shown?
I did my other ones though.
Okay, so again, game plan, if you have something that's done, whether that's the 11 to 18 or it's the 19 to 27, send it.
Or the
My
1 to 10.
impression from that brief discussion is most people should be trying to improve your even versions of the 19 to 27 because that seemed like an unfinished sort of mess. What's going on for tomorrow is we could skip taking the same quiz again. It doesn't matter to me. We could let majority rule here in just a second. Pro of taking the quiz, if you know it, is it's free points. The con is take some time out of your day to make sure you're ready for it, and then some more time out of your day to take it. The main name of the game tomorrow is the chapter review. So there's 10 questions in the book, there's 4 problems in the book, there's 2 of the applying physics in the book, so we try to take that on tomorrow as our main event, review sheet the day after, and that's the name of the game. So quiz tomorrow, you're feeling it or
Yes.
no, you're liking it,
I'll take it.
taking it, rather do it. Rather take a quiz again or not take the quiz again
This one
tomorrow?
that we just took?
The one we just took.
Yeah, I was taking
Run it back, run it back. It's already decided, back road, your vote doesn't even matter. So we'll run the same quiz back tomorrow. I'll check the one you gave me and then get it back to you in the AM if you care. Some people said you wanted some of the answers. If your practice test is handy, just ask me from that. Anybody, what answers were you short? Yeah?
51 to 50.
Can you read me what the question is? Because I don't have
Yeah.
mine handy on me.
Why does an upward force of 10 newtons on an object or an object that has a mass of 2 kg not produce an acceleration of 5 meters?
Okay, so that one, if we tried to do like the F equals ma stuff, those numbers work, but what's the loophole? Anybody a
It's-
thought?
It's
Yeah.
like, that's not like the net force.
There you go.
Yeah, it's just,
So we'd want to say something like F equals ma only works with net force, and what I was given was an applied force. So that would be probably the best answer for that. There's other ways you could say that, but something like, hey, I need a net force to do this math, and I was given an applied force.
okay.
You could keep talking if you wanted to and say like, I need to subtract the weight to, blah, blah, blah. But what's there
Can you
another?
repeat what to like write down for me then?
I would say in the shortest way that scores you would be F equals ma works from net forces, and that's an applied force.
Okay, going down the list, why does it not violate Newton's laws when a ball is rolling across the floor when it comes to rest?
Okay, it has to do with the last like 5 or so words of that law. What's the last like 5 or so words of that law, somebody?
It's like,
Unless acted on by a net outside force.
Okay, so something that's rolling across your floor is acted upon by a net outside force. What is that force?
friction.
Friction, correct. So best answer there would be say something like a net outside force is acting on it, friction. So it didn't break the rule, it followed the rule. You don't have to say that last phrase, but something like, I need a net outside force to act on it, and friction is.
Okay, last one. When an object traveling upward in a hot air balloon is released, what happens?
You just answered that for me a minute ago.
Yeah, it's the.
It's
wait.
gonna,
Right?
Oh, yeah, it's.
it rises for a little bit,
And then it's gonna stabilize.
pauses at the top for like an instant, and then
It's gonna fall.
it's gonna drop. It's not gonna drop right away. I think that's on there because like we had a problem that did that, and I think there's one more in the chapter review that does that. So if you have a rising thing, it's gonna rise for a bit before it stops and then goes. Anybody else from the vocab roundup? Any kind of questions from vocab roundup that you need? to go running it back tomorrow, same quiz moment. To catch your personal mistakes, that's now just up to me because we don't have too much time left in the period. So I'll grade these, I'll have them, give them back to you in the AM if you want them. Adjust from there. You ready, Madame Director there?
Hot.